For more than 40 years, one man was responsible for a series of crimes across California so extensive that investigators in different regions spent decades believing they were hunting different offenders. He committed dozens of rapes and at least 13 murders across multiple counties, beginning in the mid-1970s. He was known by several names depending on which jurisdiction was looking for him, and it took DNA testing in the 2000s to establish that the East Area rapist and the original Night Stalker were the same person. A journalist gave him the name that stuck, the Golden State Killer. The case went cold in the most complete sense. And then, in April 2018, police arrested a 72-year-old former police officer in a Sacramento suburb, and the method that found him did not involve any new evidence from the crimes at all. It involved a genealogy website and a family tree. The pattern began in the Sacramento area in 1976. The offender broke into homes at night, often after extensive surveillance, sometimes entering houses beforehand to unlock windows or remove ammunition from firearms. He was methodical to a degree that terrified investigators, making phone calls to victims before and sometimes after attacks, and moving between neighborhoods in a way that suggested he understood how police jurisdictions worked. Over roughly 2 years he was linked to a very large number of assaults in Northern California. Then the attacks in that region stopped, and a series of murders began in Southern California, in Santa Barbara, Ventura, and Orange counties, where couples were attacked in their homes. Local investigators there were working what they believed was a separate case entirely. The geographic separation and the difference in offense pattern kept the two sets of crimes apart for decades. DNA changed the shape of the problem twice. The first time was in the early 2000s, when improving techniques allowed evidence preserved from crime scenes across both regions to be compared, and the profiles matched. That was a significant moment, because it collapsed what had been treated as separate investigations into one, and it confirmed that a single offender had operated across an enormous area over many years. But it did not identify him. A DNA profile is only useful for identification if you can match it against something, and the standard tool for that is the National Criminal DNA Database, which holds profiles from people who have been arrested or convicted. He was not in it. So investigators had a perfect biological signature of a man and absolutely no way to attach a name to it. The case sat in that condition, effectively solved and completely unsolved at the same time, for well over a decade. The idea that broke it came from consumer genetics. Millions of people had begun submitting saliva samples to commercial companies to learn about their ancestry, and many uploaded the resulting raw data files to public websites where users could compare their genetic information with strangers to find relatives. The insight investigators pursued was that they did not need the offender to be in such a database. They only needed some of his relatives to be. Because we share measurable proportions of DNA with our cousins, a sufficiently large database will contain someone related distantly enough that they have never heard of the suspect, but closely enough to point at his family. The team, working with genetic genealogist Barbara Ray Venter, uploaded a profile derived from crime scene evidence to a public genealogy site and looked for matches. What came back were distant relatives, on the order of third cousins. What followed was not forensic science so much as painstaking historical research. From those distant matches, genealogists worked backwards through census records, birth and death certificates, marriage records, obituaries and newspaper archives to construct enormous family trees, identifying common ancestors from the 1800s and then tracing all their descendants forward to the present day. The trees ran to thousands of people. The team then filtered that population against what was known about the offender, principally his approximate age, his sex, and whether he had lived in the relevant parts of California at the relevant times. That process narrowed thousands of candidates down to a very small number, and eventually to one man, Joseph James DeAngelo, a former police officer who had served in 2 California police departments during the period the crimes were occurring, and who had been dismissed after being caught shoplifting. Identifying a suspect through genealogy is not proof, and the investigators understood that the genealogical work was a lead rather than evidence. To confirm it, they needed his actual DNA, and to obtain it without alerting him they collected discarded items, reportedly including a swab taken from a car door handle and material recovered from his rubbish. Those samples were compared directly against the crime scene profiles and matched. He was arrested in April 2018. In 2020 he pleaded guilty to 13 counts of murder and admitted to numerous rapes that could no longer be charged because the statute of limitations had expired, and he was sentenced to multiple life terms without parole. The plea meant there was no trial, which spared victims from testifying but also meant that many questions about how and why were never explored in open court. The technique did not stay in one case. Investigative genetic genealogy spread rapidly, and within a few years it had been used to resolve a large number of cold cases across the United States, including murders and sexual assaults decades old, and to identify unidentified human remains and return names to people who had been buried as unknowns. That last application is often overlooked and is among the most valuable, because it gives families an answer they had given up expecting. The technique works on genuinely old evidence, provided the sample is sufficient and well preserved, and it can operate where a conventional database search has nothing to offer. For law enforcement, it converted a category of case that had been considered permanently unsolvable into one that was routinely solvable, which is a rare thing in any field. The obvious question is whether people submitting their saliva to learn about their ancestry consented to their genetic data helping identify a distant cousin as a murderer, and the honest answer is that most of them did not think about it. The debate this triggered is serious and unresolved. The core issue is that genetic privacy is not individual. Your DNA is substantially shared with relatives who never made any choice, so one person's decision to upload their data exposes an entire family tree, including people not yet born. Public genealogy sites responded differently, with some restricting law enforcement access, others moving to an opt-in model, and the major commercial testing companies generally stating they do not permit such use without legal process. Regulation has lagged well behind the practice. There is also the question of scope, since a technique developed for a serial murderer can be applied to progressively less serious offenses unless someone draws a line. What is genuinely striking about this case is where the decisive information turned out to be. For 40 years, investigators worked the crime scenes, the profiles, the victim accounts and the physical evidence, which is the entire traditional apparatus, and it was not enough, because a perfect DNA profile is worthless if the man it belongs to has never been arrested. What finally identified him was not anything he did or left behind. It was that somebody he had never met, related to him through a common ancestor born in the 1800s, was curious about their heritage and paid a company to sequence their genome. The offender had controlled every variable he could, surveilling houses, unloading firearms in advance, moving between jurisdictions, avoiding arrest for 4 decades. What he could not control was who his relatives were, or what a stranger sharing a fraction of his DNA would decide to do with a saliva sample in 2017.